Okay, this is AP Chem topic 2.3, which is structure of ionic solids, and this one is actually pretty straightforward. So remember that an ionic bond is formed by the attraction between positive and negative ions. So this attraction causes the ions to self-assemble into a highly ordered structure that we call a lattice. Remember, we're talking about solids here. So all the positives are going to be surrounded by negatives, and all the negatives are going to be surrounded by positives. Remember that this also extends three-dimensionally. So behind this positive, we would have a negative. Now, this highly ordered structure, because it is the attraction between full charges, remember this is an application of Coulomb's law, is a really strong, relatively speaking, attraction. And that impacts the properties. So, for example, these have a high melting point. It's hard to separate them from each other so that they can change from the solid to the liquid form. Additionally, they're very hard. If you do manage to break them, though, they're going to break cleanly, and so we call them brittle. So think about it this way. If we were to bash on top of this here, and this shifted down, so that a positive was next to a positive and a negative was next to a negative, they would repel each other and you would see them separate kind of cleanly. And you might have actually witnessed this before if you've ever seen fragments of rocks, right? Because they often break cleanly because they're often made from ionic compounds. Now, sometimes we see examples of drawings where they like to use sizes to show the relative the size of the circles, to show the relative size of the atoms. And so you'd want to pay attention to what period each of the potential ions is in, and then you can assign identity based on that. So for example, this might be an illustration of the compound KF. Now we would also be proportional here in terms of making sure that your positives and negatives are balanced out. So if you had a 2 positive ion and a 1 negative a 2 positive cation and a 1 negative anion, that would be a 1 to 2 situation. But basically the same structural setup applies here, and there you go.